Welcome, everyone. We'll get started in just a minute. We're going to give a few more minutes for people to sign on, and we'll get started. Okay, great. Good afternoon and morning for our West Coast listeners. Thank you for joining us today. My name is Scott Parisi, and I'm the president of EcoGreenHotel. If this is your first introduction with EcoGreenHotel, I'm pleased to report we've been assisting hotels improve their energy efficiency and sustainability practices since 2007. We do this in several ways. We provide comprehensive energy analyses called an E2A, where we identify potential projects to improve efficiencies like HVAC, lighting, building envelope, domestic hot water production. And additionally, we provide project management services as well as rebates and incentive administration. At this time, I'm going to introduce Chris Lewis, who's our Vice President of Energy Solutions, who's going to introduce our panelists today and get the session going. Thanks, Chris.
Thank you, Scott. Welcome, everyone, to the June edition of our educational webinar series. So far, we've covered topics like 179D, AC motors, irrigation, KEMA, energy efficiency programs. Today, we're going to identify some things to look for before your properties make purchasing decisions about LCDs. We're privileged today to have Matt Sally, the business manager for LED retrofit at Terralux, with us. He has spoken on LED technology, energy efficiency, and solid-state lighting in Europe, China, Taiwan, Korea, and of course the United States. He's published in LED Magazine, Solid State Magazine, Boulder County Business Report, and many others. Joining Matt, we will have Lee Hewitt, who is the principal engineer at with the UL Lighting team. Lee's direct responsibilities with UL include certification program for luminaires, sign retrofit kits. He has written numerous technical articles, columns, and publications in trade magazines such as Signs of the Times, UL Lumens Insight, covering safety requirements for signs and luminaire LED retrofit kits in the United States and Canada. Before we begin, I'd like to bring to your attention the questions window. If you want to grab that and drag that onto your desktop, you can close the rest of the dashboard. At this time, I'd like everyone to please type into the questions box where the bulk of your hotels are, for example, California, Florida, London, whatever the case may be. Okay. Great. All right. Now, feel free to type your questions into this box throughout the webinar, and we'll get those questions addressed by our speakers, hopefully live before the end of the webinar. If we do not get to your question, we will email a response either from Lee or Matt. The appropriate person will answer your question, and we'll get that to you via email if we're unable to get to it during the call. At this time, I'd like to turn it over to Matt.
Thanks, Chris. I appreciate it. Hello, everybody. As Chris mentioned, my name is Matt Sallee, and I'm with Terralux. And what I'd like to share with you today are my observations of LED lighting's retrofit market in the hotel space, and hopefully, educate you on some of the trends and some of the things that I think you should be aware of as you consider LED lighting upgrades for your facilities. So, first of all, let's talk about what lighting is out there today. The Department of Energy presently recognizes that there are 8.1 billion light bulbs and light fixtures installed in buildings in the United States. Of that, hotels is a fairly small percentage, but 8.1 billion is a gigantic number. So on average, it's quite high. Solid state lighting, which includes LED, presently is less than 1% of the installed base in the United States. So it's a very new technology, but it is also growing very rapidly to fill those 8.1 billion light sockets. LED has a tremendous energy savings potential, and what we're seeing today is anywhere between 20 and 90% savings, and I'll highlight that 20 and 90% range today. And a return on investment, anywhere from 3 months to 3 years is typical in the commercial building space today. So let's talk a little bit about energy use. Energy is produced in the United States. There's 700 terawatt hours, that's the unit that they measure, that is produced by all of our power plants to generate electricity. And 20% of that 700 is lighting. And what that means is that there's a significant amount of the electricity in the buildings today that is used to just turn on the lights. The number one item is HVAC, which is heating and cooling equipment. And what's interesting is because so many of those light bulbs generate heat, that reducing the energy that's used by light will actually also reduce the number one category, which is HVAC. So there's a nice multiplicative effect of upgrading your lighting to LED in terms of your power bill. So if we break that 20% out across the commercial building types, there's a little bit in manufacturing, not surprising considering the inventory is pretty small. The commercial building space, which is where you guys live, this is definitely where the majority of the electricity is used. You've got long run times and other things at play. In residential, there's a little bit of electricity used for lighting, but not a whole lot. And outdoor, you kind of see the same thing. It's relatively small. So commercial buildings definitely represent, where the energy is used in lighting. So in the residential space, you've got 113 million houses and 5.8 billion lamps, but the run times are very long, very short, 1.8 hours per day the lights are on. I'm pretty sure that's in everyone's house except for mine, because I think all of the lights are on in my house all the time, and I can never keep them all off, despite my best efforts. In the commercial space, there's 5.5 million existing buildings. There's 2 billion lamps, and these have very long run times, almost 12 hours a day on average. So you can see where all this electrical demand is coming from. It's a combination of lamps and run time. In the industrial space, small amount of buildings, relatively small amount of light fixtures, but really long run times, 13 hours a day. They've got 2 shifts, 3 shifts a lot of the time, and they're high wattage, high brightness lights. So there is some consumption in industrial. If we look at the top 10 tallest cities, just as an interesting kind of data point, New York City is the second tallest city in the world. And so to look at kind of what an American city building inventory looks like, there's 327,000 houses. There's 390,000 low-rise buildings. There's 5,818 high-rises. And there's 690 skyscrapers. This is just New York alone. So in one commercial area, you can see just the density of buildings and how much potential there is to really improve the overall carbon footprint through making efficient lighting upgrades. Electrical prices. Electricity prices are around 10 cents a kilowatt hour right now and around 18 cents in New York. They are projected to rise over the next 10 years, and this is the Energy Information Administration publishing this data, and they're expected to rise pretty significantly. The reason for that is increased regulation on coal-fired emissions, where the EPA is tightening up sulfur emissions, proposing reductions of 70% by 2014, and increased reliance on more expensive and sustainable sources like wind, solar, biomass, geothermal. If we look at then the number of hotel chains that are out there, how many buildings are in this, this vertical? There are 4.7 million rooms in the United States, roughly, across 38,000 different buildings. And 90% of hotel lighting is in linear fluorescent, compact fluorescent, and incandescent technologies. And we'll talk more about the pros and cons of those technologies, especially as it relates to upgrading to LED. So here I've got then, the number one through number 39 chains here that have significant U.S. presence, the number of rooms, the number of buildings, and then you can see the breakout of the light sources. So relatively interesting information around what's going on in hotels specifically. Okay, so let's talk about the applications specifically, because this is where it really gets interesting in terms of lighting. So linear fluorescent, everyone's seen these tubes, I'm sure, because they're in a lot of places. The lifetime on these tubes is very good. These are approaching LED lifetime now with technology. The efficacy is a measure of how many lumens are produced by how many watts are consumed. So the higher the efficacy number, the more efficient the light is at producing light with electricity. And linear fluorescent is around 100 lumens per watt right now, which is exceedingly good. Even some of the best LEDs are now just starting to break into the 100 lumen per watt range, but that is making ROI on replacing linear fluorescent with LED very difficult, because there is not a lot of electrical savings, because the efficacy of linear fluorescent and the efficacy of LED are very much the same. So I get asked a lot, would you do LED tubes? And the answer is honestly that, not yet, because the efficacy is not there. You'll actually be stepping backwards if you're not careful with LED tubes in terms of light output and performance. Now, the color quality of these linear fluorescents is pretty good. They're 70 to 80 CRI typically, so that you get a lot of nice looking light. And then color consistency, I put as fair. Color consistency I define as, as these lights age, as you have them plugged in throughout your facility, they tend to change color over time, and they shift over time. And a lot of times what you'll see is some of them turn brown or green or purple. So the color consistency here, I only give them okay ranks because of some of those issues over their life. A lot of times they're used in the vanity, right above the mirror there. Always in Cove, you see these a lot, just strung around lobbies. Parking garages, absolutely, they're there. And back of house, these are great for stairwells. Anywhere you need utility light or ambient light, these are great choices. But because of that color consistency, there's some concerns. So I think what you're going to start seeing is linear fluorescent be phased out in the vanity and the Cove areas, anywhere you've got guests, and you're going to see them continue to be used in back of house and parking garage, because they are cheap and they do a pretty decent job. Compact fluorescent, these are these guys. They either have a pin on them, or they have a screw on them, or they have, it looks like we've got a quick pull here. So this is the speed round. Do you know how much longer LED lamps last compared to these CFL lamps? So go ahead and select a pole here and choose your option, and then you'll see the window close. So CFL lamps, their lifetime is fair, and that's because they have an average lifetime, are you guys ready, of roughly 6,000 hours. That 6,000 hour lifetime is not a measure of the product's true life. What it means is that 50% of those lamps will fail before 6,000 hours is reached. So if there's 10,000 lamps in your building, which is a typical number, you'll see that 50% of those will fail within 6,000 hours. LEDs, however, are typically rated at 60,000 hours of life. So if you answered 10x on the quick poll, you would be correct. Efficacy for these bulbs is fair. It's not as good as their larger linear cousin. And the reason, hey, good job. I like that everyone was able to get the poll here. That's great. We've got an educated audience. I like it. The efficacy here is a bit less because they're smaller and they're more compact. They have to deal with heat and they have to deal with lower wattages, so their efficacy is not as good. The color quality, however, is very good. They are able to manage up to 80 CRI now, and some even a little higher than that, which is good. And color consistency on these guys is actually quite poor. And the reason these are poor versus fair is these tend to age more quickly in compact fixtures, and they tend to really die in weird ways. And the fixtures that they're in tend to be highly decorative, like hallway sconces or drum pendants. And when these pendants and these fixtures start to turn green or turn brown or black out, they don't look like the way the lighting designer had put them together, and they start to really change in appearance to something kind of negative. Additionally, these are very difficult many times to upgrade and update, so they can definitely be a challenge in the maintenance department. Nobody likes getting a scissor lift out in the middle of a lobby of a hotel. That's always a challenge. These are also used in downlights, which is a great application for them. Although again, you have some issues with heat many times because these are little heat chambers that just hold the heat into the CFLs and tend to cook their brains out a little bit. And then they also go in these, table lamps. Don't mind the crazy guest there. I'm sure you guys have this guy with the pillow all around. This is not a self-portrait. Don't let Lee tell you otherwise. But those table lamps there, you can see right the one he's about to smash into pieces, use these bulbs as well. Incandescent and halogen. These are the traditional light technology. This is one of those American technologies that has been around for 100 years and still is there, like the paperclip and the mousetrap. It's just one of those things that just won't go away because it's relatively good at a few things. It's not good at lifetime. These lamps have very short lifetimes, some below 3,000 hours of use, which in a typical environment is a 12-hour runtime environment is 3 months or less. The efficacy is quite poor. That halogen lamp on the top there is between 8 to 10 lumens per watt, so 10 times worse than fluorescent. Color quality, however, is excellent. These do output a full spectrum, and many of these lamps are 98 or 100 CRI. And the color consistency is very good. These tend to fail in the same way in a repeatable fashion. They just get warmer and warmer, and everybody likes warm light, especially in hospitality. It's very appealing in wall sconces where you need 360 degrees of output. It works great in track lights. Those halogen bulbs are very punchy. You get a nice tight spot of light that's very intense and has very good color. In pendants, lighting designers love these hand-blown glass things hanging over hotel bars and reception areas. They definitely look beautiful with the shades illuminated. And in step lights, you would not believe the number of step lights that we find clients have that have 100-watt or 300-watt halogen bulbs inside of them. And it's unbelievable how much energy they're actually using to create this tiny amount of light. So those are some of the typical applications in hotels inside the building. So if we move outside the building, a lot of times what you'll find are these high-intensity discharge lamps. The lifetime on these is fair. They don't last as long as the linear fluorescent lamps, but they do last a long time, mainly because they degrade quickly right away, and then they kind of slowly burn out. So when you first plug one of these guys in, they'll be really, really bright. And over about 3 months' time, they will degrade by 30 or 40%. And then they'll just kind of start the slow death march to the end over a number of hours. The efficacy on these guys is excellent. These are up there with Fluorescent in terms of, breaking that 100 lumen per watt barrier, which is great. The color quality is just okay, though. The color quality, these guys are lucky to get into the 70 CRI. There's some performing bulbs that get into 80, but mostly in sodium and metal halide, you're looking in the 20 to 50 range. Some of the low-pressure sodium bulbs are actually negative CRI because they're pulling out color. So if you've ever stood under one of these, you know it, because all you can see is orange. Everything is orange. Green is orange, gray is orange, brown is orange, red is orange. Everything is orange. And the color consistency on these is again, poor. Like the compact fluorescent, these age in strange ways and many times can turn all the colors of the rainbow depending on what they've been exposed to. And that can cause, some interesting visual effects depending on where they're used. When you use them in a hotel like this, you've got to replace them pretty frequently because you want that consistency to be very high. You want all of those uplights to look the same and that hotel to stay looking beautiful. But in parking and pathway, it's not quite as big of a deal. If you're just, trying to light the way and provide some security and parking lot lighting, it's not nearly as a big deal that color consistency is, not so good. Same with parking garages. As long as the light's on and you don't have a security issue, that's really the most important thing. But this is where LEDs do have some advantage because they do offer consistent light and they do allow for longer lifetimes, so you don't have to worry so much about your security lighting burning out. So just to recap a little bit and talk about things to consider, indoors you actually have quite a few 24 hours a day, 7 days a week run times. These are the best locations to find energy savings and to start your LED retrofit, because hotels have a unique situation where the lights are always on, and these are the best places to look for energy savings with LEDs. These include corridors, hallways, stairwells, elevator lobbies, and you can see some pictures here of drums and wall sconces that use these fixtures that are on 24 hours a day, 7 days a week. Lighting in these applications should consider theft and security. That crazy guy jumping on the bed with the pillow is no mistake. You for sure have those types of people walking through your buildings every day, and I'm sure that you all would shake your heads yes up and down that you have lost light bulbs. The last thing you want to do is screw down a $30, $40 LED light bulb into a socket only to have it walk away the next day. It sounds like you guys had a recent webcast on tax credits, so that's good. You have some ability to get tax credits in your building, but you do need to consider that the LED solution needs to be able to bi-level dim. This is typically done through a 0 to 10 volt connection using occupancy sensors, daylight sensors, but you want to make sure that your LED solution does have that ability, because then you can take advantage of the tax credit. You also want to choose a high-quality LED. You don't want people to know that you've changed to LED. Good LEDs don't look like LEDs. That's what I'll say. They look like light. They don't look blue. They don't look green. They look like any other type of high-quality light. And whenever you're doing a retrofit, you should consider bringing the quality up, not down. And maintenance. Don't underestimate maintenance or replacement costs, and we'll talk more about this as the webcast goes on. Labor can be as high as $120 an hour in New York City, which is the union prevailing wage. So, just screwing in a light bulb, no big deal. Not always. There's some very expensive places to replace lights. Outside, You know, we talked a little bit about step lights and some of these decorative wall packs around entrances and down hallways and out around the pool. Your lighting should consider rain, dust, and debris. You'll want to look for solutions that have UL wet location ratings or IP65 ratings that will allow them to cope with dust, rain, and moisture, because even some of these best sealed fixtures can leak in high wind and rain. You also need to consider thermal protection. If those lights turn on during the day and you're in Phoenix, Arizona, and it's 120 degrees outside, what's going to happen to the LEDs? Sunshine and heat can be killer for unprotected LEDs. So we'll talk a little bit more about what to do there to protect them. And then you need to think about your light needs. A lot of times outdoors, you know, a certain type of light was specified, and maybe it's really obnoxiously bright. So in a lot of cases, you should consider what light you actually need, because any light that you're producing that you don't need, you're just wasting energy. Also, consider dark skies. Everybody likes to see the stars, including your guests. Consider how much light you actually need to do what you need to do. Maintenance, don't underestimate replacement cost again, outside. You know, these labor rates can be just astronomical. So if we rethink lighting efficiency a little bit, you know, historically what the way of lighting has been is to create these 360-degree sources and say, okay, now I'm throwing light in every direction. Now let's put this inside of a fixture. Perfect. Nice. Fixture looks good. I've got light going up. I've got light going down. I've got light coming into the hallway. Nice. But the fixture is not outputting 360 degrees. The fixture is only outputting 90 to 180 degrees. So any of that light that's not making its way out of a fixture, and believe me, there's a lot, is what energy that's being wasted. And in the testing that we've done and the evaluations that we've seen, that can be anywhere from 40 to 70% in many of these fixtures. So allow me to propose to you a way to consider an LED project. So here are 4 typical hallway sconces that we found in a hotel. These look the same, but they have 4 different lights inside. So I'll take the cover off. I'll turn the lights down so you can see them. And what you'll see there is a 60-watt incandescent light bulb, a 13-watt CFL, a snow cone LED light bulb, and a linear engine LED retrofit kit. And what's actually happening here is that you get a very similar effect from all of them, except the screw-in LED light bulb, the bottom third of that fixture is dark because, that's right here. The bottom portion of that fixture is dark because of the lamp holder and the snow cone effect that you've got. But when you put in an LED solution that fills the fixture space evenly and is only outputting light where you need it, which is into the hallway, you get a brighter fixture and you get more even illumination across the face of the fixture. It actually makes the fixture look as good as or better than it did before. And that's the whole idea with LED. Improve the light quality as well as the energy savings. You can have both. So to give you an example, here's the energy savings. 60 watts versus 14 watts versus 10 watts versus 8 watts. And the reason we're at 8 watts instead of 10 is because that we're able to save that extra 2 watts because we're not wasting light inside the fixture. And in this case, we're actually using the fixture as the heat sink, so we don't need rocket ship fins on the outside of our product. So let's talk about some technology that you can consider in your hotel retrofit. That particular product fits well for pin CFLs. Right now, there is not a lot of solutions out there for pin CFL fixtures, which every hotel has tons of. And these are a good solution for that. These are a simple installation. These are as easy to install as a ballast. They're line voltage connected, and you can connect them either to 120 or 100 to 277, so they're universal input. And all you do is replace the ballast and the bulbs with this. So you're taking out typically 2 bulbs and 1 ballast and putting this inside. It simplifies the fixture. It's securely mounted inside, and it has a lot of other features here. I won't walk you through all of these, but you can see what some of them are. It's compatible with dimming systems. It's suitable outside, and it has a 5-year, any runtime, any application warranty. We don't care where you put this or how long you run it, and that's one of the things to look out for when you're looking at LED solutions, is really look at the fine print on the warranty. A lot of them say, you know, warranty not valid for commercial installations, or warranty only good if product was run for 2 hours a day. We don't say any of that. We put our warranty that you can stand behind. 24 hours a day, 7 days a week, plug it in, run it, no problem. And then these are UL classified for retrofit installations, which means you get to keep your existing fixtures. Like wall sconces. Here's example sconces that have been completed. Wall sconces are a great way to find savings because they are typically 24/7 applications, and you can find large wattage reductions even against CFL. Plus, LED solutions can offer high security and extremely low maintenance. So a typical wall sconce, that Hawaii hotel one, that one has had one ballast and two 13-watt CFLs in it, which was roughly a 34-watt load with a ballast factor of 0.9. We put in a 11-watt LED solution inside, and that was a 66% energy savings against CFL. And the kilowatt hour in Hawaii is extremely high. It's 35 cents an hour, a kilowatt hour. So we were able to find ROI was less than a year to complete that project. A great example of LED working perfectly, exactly the way it should. Lowering energy, increasing color quality, and helping save money all around. Wall packs.
Hey, Matt, this is Chris. We've got a few questions that have come in over the last few minutes, but one that I think might be appropriate here is the question is, what about the LED decay time? What is the life cycle? You were talking about warranties earlier, so I thought this question might be appropriate now.
Sure. On this particular product, we do a couple of things to predict LED lifetime, and one of the things we do is we do LM80 testing here on our LEDs. And what LM80 does is LM80 is a specification that predicts how long the LED will last if it is run at the right temperature and the right power level. And what we do is make sure that we're always running the LED in its comfort zone so that we know the LED will not shift color over time and it will not degrade faster than we're expecting. So over 60,000 hours of use, our LED products will only lose 30% of their light output, and they will stay the same color that they are when they were originally turned on. So what that means is 60,000 hours of use is almost 6 years at 24/7 runtime, and it's 15 years at 12 hours a day. So that's exactly why we have a 5-year warranty, because that covers up to that LM80, that 60,000 hours of use in that 5-year time frame. That's a 24/7 operating warranty. So that allows us to, say that we've tested this, we've evaluated it, and we know that that's where it's going to go. Most probably, it's going to continue to run. We have some of these engines on long-term tests now, and I'll show you pictures of that later, that have now started to break into the 40,000-hour lifetime, which is really great. And the only way to get there is just to run them. So we've been running them and running them and running them. Good question. Thank you.
I know you're speaking specifically about the Teralux product. Is that typical across the board for the brands, about 5 years on the lifespan of the LEDs, or can that vary greatly from brand to brand?
It's not typical. You should actually evaluate the claims the same. So you should always look for how many hours is the product rated for, because if someone ever tells you that their product is going to last for 20 years, you immediately need to ask, how many hours per day are you talking about? Because a lot of times there's hidden text there that says, our product will last for 20 years when you run it 2 hours a day. Well, that's great, but the reality is a lot of these fixtures in commercial buildings are running for 12 hours or 18 hours or even 24 hours a day, and that's not a representative case of true product lifetime. So you just need to be careful with what's being said, and folks like EcoGreen can actually help you, evaluate quality products to put into your buildings. So in the wall pack space outside, again, you see a lot of these types of fixtures, and these fixtures have a lot of potential to save energy. These have significant wattage reductions, and they're extremely low maintenance. A lot of times these fixtures are way up in the air and difficult to get to. Put LED in, you're done. Leave them alone. You don't have to touch them again for 5 years, 10 years, whatever the case is for how long they'll be turned on. Step lights are an especially difficult one to retrofit. These are very thermally compact and challenging. Again, solutions that can bolt down to the inside of the fixture and use the fixture for cooling are preferred, because these are able to perform well, and these are typically 24/7 applications, because step lights, you have to have at least 1 foot candle of light on the ground in these areas, so they're there for a reason. Downlights are a lot of corridor lighting that we've seen in hotels. A lot of times they're drywalled in and you can't get to them to upgrade. So one of the solutions here, and here's an example of a 2x13 or 2x18 pin CFL. What we do is we've created a downlight kit here that allows you to use the existing reflector and housing, and you simply install it in the reflector trim and whip around to line voltage, make a connection in the junction box just like you would with the ballast, push the trim back into the ceiling, and you're done. You've got 2 bars of light where you had 2 bars of light before. And this particular product is ENERGY STAR certified for this application, which means you'll get rebate dollars, and we'll talk more about that in just a moment. Track heads and MR16 type products. Yes.
Matt, let me interrupt you for a moment. I guess I apologize, but I do have a question from the audience. When you anticipate getting your ENERGY STAR rating?
We have ENERGY STAR on numerous products presently.
Okay. And we have a couple other questions I'm going to fire at you. They're piling up, so I'd like to try to get a few in here if I can.
Okay, sure.
What are the different standards in manufacturing, and what are the features of each? So from a manufacturing standpoint, are there, I think you may be coming up to that kind of conversation later, so we could address that.
Yeah, I will address that one, yeah.
Okay, great.
Okay. In the MR16 space, it's important to look for products that actually deliver the same lumen package as the MR16. Again, there's a lot of claims being made that a lamp or a track head that's producing 300 lumens is equivalent to a 50-watt halogen. That's not true. A 50-watt halogen delivers over 700 lumens and has a very intense center beam candle power. So you need to be educated on how many lumens you're actually producing. This particular product that I'm showing you is a true 50-watt halogen equivalent. It is 700 lumens, and it does have the same center beam candle power as a 50-watt halogen. Additionally, it allows you to do push level dimming, and it has field replaceable optics. So you can change the beam angle and the light output to suit your needs. And this is UL certified, and it also has ENERGY STAR pending. We're just waiting on the EPA to finish their paperwork. But this is just an example of a high-quality LED product that really meets the spec. Another product that we've developed and is a Teralux patented product is our decorative MR16 lamp. This particular lamp is cool because where a traditional halogen will light up a pendant shade like this with the dichroic reflector, when you plug in an LED lamp, just an off-the-shelf one, what happens is the shade turns dark because of the heat sink. And what we've done here at Teralux is we've put small LEDs, low power here in the back, and illuminated this lamp holder. So what you get is a shade that's illuminated as good or better than the existing one. And what we've also done is put in a 96 CRI, which is industry leading. This is using Sharp's latest Zengata LED, which is one of the best performing CRI LEDs on the market. This particular product comes with a 3-year warranty. And the reason this one comes with a 3-year warranty is because this is a very compact form factor and it is very bright. But that is a typical rated lifetime for high quality LED MR16s. One of our new products that we're coming out with will allow you to retrofit into these drum circle line fixtures where you have circle line bulbs or you have 2 or 3 PLs inside. This will slide right over the center ring here and illuminate. You can even mount them back to back so you can light the ceiling and the floor. They're great for welcome lights. We'll begin production shipments in fall of 2013, and this will be an ENERGY STAR certified product when it comes out, and is really impressive. If any of you go to the Light Fair show or are planning on going to that in the future, come by and see this product. It is very exciting, and we're really excited to get this into hotels. Let's talk a little bit about return on investment now. So I want to kind of switch gears into how to know if you're making a good LED decision. So the ROI calculation for LED is a combination of energy savings, maintenance savings, utility rebates, project financing, and just an organizational desire to go green. Energy savings is a combination of utility rate, runtime, and wattage reduction. So I mentioned before, all of these interior fixtures have 24/7 runtimes. That immediately impacts your energy savings very positively because that's as good as you can get. Then if you have a high utility rate and a high wattage reduction, you've got a winner. That's a great place to start your retrofit. Maintenance savings, you should consider what the replacement interval is on the lamps. If you feel like there's a fixture that you're replacing a lot, like you're always pulling ballasts out of your downlights or you're always pulling those lamps out, that's a good place to start because those trouble fixtures are the ones that are primed for LED, because when you put the right quality LED product in there, you can stop the maintenance cycle on those. And again, don't underestimate labor here. A lot of times you're dealing with union. Utility rebate programs, these tend to be based on a per fixture amount, and they tend to look at run times or annual types of calculations, or they may be based on the reduction of kilowatt hour that you're saving and issue you a percentage of that. So they vary. But there are utility rebate programs available for LED lights, and you should definitely take advantage of those. And EcoGreen can help you determine those. Project financing, in a lot of cases there are product financing that will help you with the initial outlay, and they can be quite affordable. And then going green, a lot of people just tell us personally that they want to go LED because they want to go LED. That's what their guests want, or they want to have a sustainable message. So that's what they look at. Now, in terms of what really drives ROI, this is what really drives it, the dollar sign here. So maintenance is a big one, energy savings is a big one, and utility rebates are a big one. And sometimes project financing can be the make or break, but mostly it's maintenance, energy, and rebates that really drives ROI in LED retrofit. So a typical maintenance savings example, here's a wall pack. 170 watt metal halide with a ballast. It's on 12 hours a day, 7 days a week. It's about 80 watts because the ballast is not 100% efficient. The lamp life is measured by a 50% failure, so what you're doing is probably replacing the lamp once a year, and you're probably replacing the ballast every 3 years, and it's probably costing you, to the left, to the right, $25 to replace the lamp and ballast. That's because you got to get a ladder out, and then you've got to find the bulb, and you may have to order the bulb or the ballast, and you've got to go back and forth a couple times, and then you forgot the screwdriver that you needed because you got a Phillips and it's a standard, and there's all kinds of things that go into that. But on average, we're saying about $25. So for every fixture in your building that looks like this, you can estimate that over 15 years, it's going to be about $1,400 to maintain that fixture, to keep light coming out of it. Now, if you upgrade it to an LED, keep the same fixture, upgrade to LED, you get a similar light output. Now you're only running 13 watts. You've reduced the energy output by 84%, and now you're not replacing the LED at all over that 15 years. So your estimated labor is the same, so your cost over 15 years is $105. That's payback in about 1 year, and that's only on maintenance. This doesn't include the electrical savings because I don't know what your kilowatt rate is, but this is only maintenance. So as soon as you put in a utility rebate and as soon as you put in energy savings here, that number drops way down. This is a no-brainer for your finance guy to sign off on. This is the easiest application to find savings in your building because the wattage reduction is so high and the maintenance cost is so high. Another maintenance savings example, the wall sconce. Here we've got a wall sconce with two 13-watt PLs inside and a ballast. These are interior lighting, and they're a 24/7 runtime. The CFL life here is measured by a 50% failure rating. So again, these are looking at replacing the lamp every year, replacing the ballast every 3 years, and the labor to do that is about $10. These are pretty easy. So you can see your costs here over 1, 2, 3, 5, 15 years. It's about $400 to keep this fixture running for 15 years to be feeding it bulbs and ballasts. If you upgrade it to LED, you put in one 6-inch LED here, you get 11.5 watts, so you're reducing the wattage by about 66%, and your LED life is 60,000 hours here, so you're doing one of these over that 15 years, and you're at $85. So again, your payback here is very fast. You're about 3 years, and this is just maintenance. This does not include any potential utility rebate, which could be, up to half of that $85, and energy savings, which could easily outstrip that. So when you put in energy and you put in utility rebates, depending on where you're at, this could be, under a year or within a year and a half of ROI, which is fantastic in this particular fixture. So a little bit about utility rebates. Utility rebates are very complicated. There's 383 utilities across the nation, and most use Energy Star or DLC to certify rebate dollars. And Terralux, as I mentioned, does have Energy Star certifications on their products, and we're working with DLC to create a category for new products so that you can use in some of your buildings. We are a contributing member to the DLC and are working with them on a technical level. If you want to know what rebates are available in your area, you can use desire.org. This website is run by the Department of Energy, and it is a database of all the rebates that apply for your property. So it's a really nice website to go to, dsire.org. The energy efficiency gains and regulation changes around the country. Suffice to say that red states do have efficiency regulation where they have to meet specific demands, and the yellow states have goals. So if you're in one of these states, you probably have to be doing something in your building to stay efficient. And again, this is all from desire.org. It's just interesting to see the country change with efficiency goals. So another thing to mention is that double rebates are available. Terralux has just introduced our own rebate that is on top of any utility rebate. So not only do you get a utility rebate, but you also get a Terralux rebate. We're doing this to help accelerate the savings that buildings can see to upgrade to LED. So you can, my contact information will be on the end here, or you can contact EcoGreen, and they'll walk you through how to apply for this. It's very simple, and it will really accelerate your savings. In addition to that, there's also energy codes that allow you for tax deductions. It sounds like you've already covered this in a previous webinar, so I'll just put this out there for your information that there are tax credits that are available for you, depending on what you're doing and where you're located. So you can work with EcoGreen, and they can help you understand what and where those are.